What if I told you that the discovery of a scientist citizen helped NASA find out something that was under their eyes for some years, like from 2020, and now it's a clear sign that something is happening on Jupiter and Saturn by observing a brown dwarf like 20 light years from us? While today we talk about a happy accident as was defined in deep space. And that's because astronomers using NASA James Webb Space Telescope made a serendipitous discovery, a previously overlooked brown dwarf humorously nicknamed the accident. Because yes, if you talk about the accident nowadays in the last week, in the last month, well, everyone in the field refer to something that happened in the astronomy field, and thanks to discovery that was made in 2020 by citizen scientists. So a common, well, I would say, a person who is a scientist of the US and whose job is not being an astronomer, but through the project Backyard Planets, was capable of observing an anomaly within a brown dwarf, which helped NASA infer this data and discover something very much closer within our solar system, within particularly Jupiter and Saturn, the gas giants. Well, this object, the brown dwarf, was originally discovered in 2020 by a citizen scientist, as I was saying, and the name of the project is Backyard Worlds Planet 9. And the data was not clearly taken from a telescope in the backyard, so it's not a common telescope, but it's the data come from the NEOWISE. What was called initially WISE and then renamed NEOWISE mission. So this person got the data from this mission and then analyzed. And the point is, why is this defined as an accident? But before going on, I want to tell you something related to telescope. Recently, we have partnered with Dwarf Lab, and we have received a Dwarf 3 smart telescope to try it and to observe the cosmos in a very smart and amazing way. So that's a great way where and how you yourself can make amazing discoveries by just observing the night sky. Well, if you have seen our latest video, it was taken by the SpaceInfo Club team observing the latest lunar eclipse, and it was taken directly from our backyard. So also the light pollution was quite high. There were street lamps polluting the image basically, but we were able anyway to get the full eclipse and observe it, and the result was amazing. It's super easy to set up. It's called smart because it connects directly to your smartphone through Wi-Fi and Bluetooth. You can have at your disposal a lot of settings through which you can observe the night sky. There are a couple of filters. There are also, and I mean hardware filters, to observe the sun. You can put them over the lens, couple of lens, wide angle and also telephoto angle. So the potential of this little so big thing are huge. So you can see our video of the eclipse, you can see our video of the unboxing, and go and visit the spaceinfo.club website for further details. And if you want to buy one, it's a super competitive price with a special discount for special occasions. You can digit dwarflab.com !AFF equals to 230, which is our affiliation link, and you can get directly to your home the Dwarf 3 Smart Telescope by Dwarf Lab. But back to us. What makes the accident unique? Well, the accident is a brown dwarf, so a celestial body, a substellar object that's larger than a planet, but not, this is the point, massive enough to sustain nuclear fusion like a star. Indeed, Let's compare it. You have planet and exoplanet, then you have brown dwarfs and then stars. This is an artist concept that we took directly from NASA website. So for the credit, go and visit their website. The article related to this discovery and this article reproduction is credited to them and to the artist that made this amazing artist concept. So it's up to 13 times the Jupiter's Mars, 13 to 18 times Jupiter's Mars. I'm talking about brown dwarfs now, and the stars are over 80 times Jupiter's Mars. So Jupiter is the benchmark this time, and we are talking also about brown dwarfs. Is particularly unique. It's so intriguing because it displays a mixed what's said as array of physical features that are seen both on what could appear as opposite lifespan, opposite phases of life of a celestial body, particularly young and on the other hand ancient brown dwarfs, and it makes difficult to classify with standard methods. That's why let's say professional astronomers, professional astrophysics did not notice this particular behavior, this particular chemical signature, because the point is that if when you use standard models, you have standard procedures, standard, let's say, things that you go and analyze that probably are so powerful, but maybe in rare, fortunately very rare cases, can hide some anomalies that could turn out to be very interesting discoveries. And the point is that located about 50 light years from Earth, and it's estimated this brown dwarf is estimated to be between 10 to 12 billion years old. And this is a very particular number because it ranks among the oldest brown dwarfs known. If you think about it, the age of the universe, which is 14 billion years, you can understand how old this accident is actually. And using the Webb, scientists detected silane, which is very particular. It's quite common. It's a chemical element, molecule. Formed by silicon with 4 atoms of hydrogen, and it's kind of simple molecule. In this brown dwarf's atmosphere there is a huge amount of this, and it's the first ever confirmed detection of silane in such an object. If you have followed our content in the previous videos we have published, and you can look for them, and they're quite recent, like last month when this video will be published and released, but you can look at them. It's about K218b exoplanet, couple of videos. We talk about 6 sigma, 5 sigma, and the accuracy of detection of in this case substances, or it's the gold standard, which is 5 sigma for the accuracy or the probability of detecting something within a medium during a research process. And this is related to what we're talking about. So go and go for that content if you want more detail in this sense. So this is the first ever confirmed detection of silane in this kind of object. Silicon, it's quite common in the universe, but has been notably missing from observation of the atmosphere of Jupiter, Saturn, and similar gas giants, and more general also outside of our solar system. And this is the point. And finding silane, which is 1 atom of silicon bonded with 4 of hydrogen, makes this discovery particularly interesting. Indeed, in gas giants, silicon typically binds with oxygen, not with hydrogen, and by binding with oxygen it forms silicate compounds like quartz, which are very heavy, and also form cloud particles. It's more technically speaking, it's said to seed cloud. So in the cloud formation evolves around the the physical phenomenon that if you have a center of nucleation, so like think about when you open a bottle of gassed water, well, you see the bubbles coming and forming. So that sort of, the formation of those bubbles is related to, let's say, what we could define, not technical speaking, about anomalies in the medium of the water. So bubbles are formed in particular places where the water is not pure 100%. This is the very same idea behind the formation of clouds. If you have, I would say, pure air, which is not chemically and technically correct speaking, but gives you an idea. If you have clear air, it's very difficult to form clouds, as it's let's say widely known. But if you have some little protuberances, like different molecular, different pieces of medium within a more uniform one, well, it's far more probable that around those anomalies you will have the formation of clouds. This is what happens. So you have cloud particles which seeds the formation of clouds, and these particles are something like silicate compounds. They are heavier though, so silicate clouds are thought to sink beneath upper atmospheric layers. So for example, below water or ammonia clouds, so water vapor, ammonia vapor, and so finding silicon is quite difficult. So it's basically this compound and this atom become invisible to the probes and the telescope observing from outside the atmosphere. But the thing is that the detection of silane is the accident, and this suggests that under low oxygen condition, silicon may instead form lighter molecula like silane indeed, which well basically could remain in upper atmospheric layers. And the result provides a critical chemical clue. It helps explain why silicon hasn't been observed in Jupiter and Saturn. It's hidden deeper under layers or locked in oxygen-rich compounds. This is the thing. So now the point is, what's the relation between oxygen or silicon and other compounds in the atmosphere? Well, JPL, Peter Eisenhardt, noted that the researchers weren't aiming to solve a puzzle about Jupiter or Saturn when initiating their observation of these brown dwarfs. So the discovery is quite a serendipitous discovery. So sometimes extreme or unusual objects, well, illuminate the ordinary ones. This is the point. So Faraday, the lead author of the study, echoed that, this statement that we can report, that studying an extreme outlier like the accident can reveal mechanisms at work in more typical planetary environments. So why is this important? So the role of that oxygen plays in trapping silicon deep in clouds. Well, the discovery opens a new window under the understanding of the atmospheric chemistry of gas giants, especially regarding how silicon behaves under different environmental conditions. This is the point. So, well, it helps for sure scientists refine models of weather, cloud formation, and also chemical processes in both our solar system and gas giants. Well, on distant, yes, exoplanet. That's what we talked a lot also in the past, and this is the point. So also, I would like to add something about the brown dwarfs that you've been asking us before the publishing of this content. So why are they special? Well, they are special because in particular these, or let's say the accident, so these brown dwarfs is special because of its age. So due to its age and dimension, it's special because the point is that a lot of similar celestial bodies have a lot of oxygen within its atmosphere. So the bond between silicon and oxygen forms the silicates, which are quite heavy, and so the result is that these compounds, well, go deep beyond the upper layers of the atmosphere. But why is the oxygen absent in these brown dwarfs? Well, this is related to its age. In the very first instance, in the very first um, times of formation of this brown dwarf, oxygen was not so present, and this is particularly related also to the gravity of this body. Being a brown dwarf, the gravity is not so strong to enhance the pressure that's on the within this celestial body. So nuclear fusion is not triggered, and so heavier elements, the metallic ones, and by metallic I am astronomically speaking, so the metallic elements are not formed because the nuclear fusion is not activated. So simpler elements like hydrogen, helium, and those ones cannot be transformed through nuclear fusion in heavier ones like oxygen, and this oxygen cannot bond to the silicon which is actually present. So you have bonds of silicon and hydrogen, and so silane. This combined with the absence of oxygen in the atmosphere, then that you won't have silicates, and those are the points. So you will detect silane, and this is the thing behind the discovery. So this is particularly important because highlights the value of citizen science programs and powerful observatories like the Webb, which validated the data taken from citizen scientists. Well, discovery ray phenomena with a wide-reaching application is the point between these things. So what can you do for sure on your side? So if you are particularly curious, and also if you have came up to this point, you can visit spaceinfo.club/learn, where you can find free and also premium courses, and you can learn something new every day from me, from our team, and also from all the experts from the fields who are professionals and work in the space field and can teach you something new and something super interesting every day. So thanks for watching. See you next time.